Hope you had a good winter break. We do have some notes to take today. So we're going to do just a quick review on how to find slope. So I've taught you how to find slope from a graph, from a table, and from 2 points. So we're just going to do a quick example of each. In your notebook, let's first talk about all the different ways to represent slope. So let's write slope right here. Okay. In algebra, we have a variable that represents slope, which is the lowercase m. So m, when we're talking about linear equations, means slope. And slope is just how steep a line is, right? So we have learned to find slope by finding the change in y over change in x, which looks like that. Well, delta y over delta x, triangle y over triangle x. Well, what that means is the change in y. So you find the difference in your y values and you divide it by the change in x. So divide it by the difference in the x values. When we're looking at a graph specifically, we like to call this rise over run. It's probably how your parents learned it, and you might have even learned it last year. So how much did it go up or down? That's your change in y. And then how much it went over. That's your change in x. So rise over run means the same thing. Rise is your vertical change. Run is your horizontal change. And then we also learned a fancy formula. There's actually a slope formula. We use this most often when we're doing slope from 2 points. So you would take your second y value. So we do y2. And we would subtract our first y value. So y2 minus y1 on top. And then on the bottom, you have x2 minus x1. So that's really just your second x value subtracted by your first x value. Okay, and all that is the change in the y values divided by the change in the x values. But we do have to be comfortable with all of these different ways to represent slope. Okay, so next, let's go ahead and do slope from a graph. Okay, so slope from a graph. I would suggest slope from a graph. I would suggest to stick in your head like, oh, okay, that's when I do rise over run. Now, some of you might like to think about it as vertical change divided by horizontal change. Beautiful. Some of you are still in the mode of change in y divided by change in x because it works for everything. Good. Okay. But rise over run is the same thing as change in y over change in x. Okay. So the rise, we'll look at how much the 2 points went up or down. And then the run, we'll divide it by how much it went over, left or right. Okay. So let's go ahead and write some steps in just so we have them. So when given a graph and asked to find the slope of it, so there's already a line graphed on it, first thing you're going to do is pick 2 points on the line. And you're going to start with the point on the left. Okay, so pick 2 points on the line. So identify 2 good points. There might be more than 2, but you just really need to. Start with the point on the left. I just always start with the point on the left. I suggest you do the same. And then after that, next thing we're going to do is we're going to find the rise. Okay, so you can call this find change in y. You can call it the rise. You can draw a little arrow going up or down, but you need to find that vertical change. So starting on the point on the left, figure out, did it go up 4? Did it go down 5? Whatever it might have done. Okay, so figure out how much it moved up or down. Next, you're going to find how much it moved left or right. So that's your change in x, which we like to call the run. So that's how much it moved left or right. Okay. And then after you find the rise and find the run, the last thing you would do is you'd go ahead and simplify it because it is a fraction, rise divided by run. Okay. So a lot of times you will have a simplified answer that's a fraction, and that's okay. We'd rather it be a fraction than a decimal because it's nice to see the rise and the run, okay? But when you divide, if it comes out to be a whole number, that's fine. That's beautiful. Slope can be a whole number. That's fine. But when in terms of fraction versus decimal, it's better to have slope as a fraction. Okay. Okay, so we're going to do an example. So I'm hoping you can kind of squeeze in a little baby graph over here. And let's see if you can go like 3 tick marks in each direction. Okay, here's X, here's Y. Typically the line would be on there for you. So I'm gonna go ahead and like kind of do an example. Oops. Notice I don't know where my ruler is. So I'm using a sticky note. So you would have a line already on there and you would need to pick 2 points. So like right now I see a point, a good point at, I did not spell that right, but -1, 3. Okay, we'll call it -1, 3. And then I also have a point down here at 0, -2. So on your little notebook, see if you can set that up, okay? All right, and then next we're gonna find the rise and the run. So the rise, so I'm gonna start with the point on the left, which is this guy. And I'm gonna see how much it went up or down. So we're going down here. So it went down 1, 2, 3, 4, 5. It went down 5 units. So my rise went down 5. Since it went down 5, we represent that as a negative value. If it would have gone up, that would have been a positive value, okay? And now we're gonna find the run. So from here to here, how much did it have to go left or right? Well, it went to the right 1 unit. Since it went to the right 1 unit, that's a positive 1. So we have -5 divided by +1. And then we go ahead and we simplify. Use a calculator if you need to, but I hope that you know -5 divided by +1 is just -5. So your final answer here is -5. Okay. So it is possible for slope to be a whole number like that, like -5. Next, we're going to go to slope from a table. So let's set up an XY table here. And give yourself enough room for 4 ordered pairs to be put in there. So when I think of a table, I think of rate of change, finding the rate of change, and rate of change is the same thing as slope. And how we did rate of change is change in y over change in x. So it's the little like triangle things off to the side, okay? So let's go ahead and fill in our values in the table. Here we go. We got 20 and then 2. 5, 5, 0, 6, -30, 12. So make sure you got that written down correctly. Pause the video if you need to get caught up. Okay, so I want to find all of my changes in y and divide them by the changes in x. So we're going to look at the first 2 ordered pairs from 20,2 to 5,5. Let's look at the change in the y values. So how did 2 get to 5? It added 3. So our first change in y was +3. I go to the x values, the x side, from 20 to 5. How did 20 get to 5? It went down, so we show minus, it went down by 15. So 20 minus 15 is 5, right? So our change in x is -15, okay? And let's go ahead and just find all the changes in y and x and we'll simplify at the end. So next, I'll do this in a new color. We go to our next change in y from 5 to 6. That's an increase of 1. And we go to our changes in x from 5 to 0, that's going down by 5. So we have to show that it's negative 5 for our change in x. Okay, and then the last changes from 6 to 12, that's an increase of 6. And from 0 to negative 30, that's decreasing by 30. So we would have positive 6 over negative 30. So we found all of our changes in y over changes in x. Now we need to simplify though, okay? And that's what some of us are forgetting to do or struggling to do, to be honest. So simplifying fractions, if you type that into YouTube, you might want to check out those videos. 3 and 15 can both be divided by 3. So 3 divided by 3 is 1. 15 divided by 3 is 5. So 1/5. But positive divided by negative is negative. So it'd be negative 1/5. I think the best thing you can do is to stick that negative kind of out front of the fraction. Okay, let's go to this next one. Positive 1 over negative 5. 1 and 5 don't have any common factors, so it's already simplified. But positive divided by negative is negative. So I'm just going to stick that negative sign out front. Last one, 6 and 30 are both divisible by 6. 6 divided by 6 is 1. 30 divided by 6 is 5. Positive divided by negative is negative. So I stick that negative sign out front. Notice that they all simplify to the same amount. That tells us that this is linear, remember? So all the points line up in a straight line. Cool. That means it has a constant rate of change. Constant rate of change is negative 1/5. But most importantly, it tells us the slope. Your slope is negative 1/5. Okay. Okay. Last one, slope from a table. Oops, sorry. Slope from 2 points. Whoops. We already did the table. Slope from 2 points. So like I give you 2 ordered pairs and you tell me what it would equal. Making a little bit of a change here, sorry. Okay, so slope from 2 points. If you remember the formula, you take your second y value, subtract your first y value. And then underneath on the denominator, you take your second x value and you subtract your first x value. Okay, so that's the formula you would use for slope from 2 points. Okay, so let's say I give you these 2 ordered pairs. So your first one is 7, negative 3. And the second ordered pair is 4, 1. So question would be, what is the slope from these 2 points on a graph? Okay, instead of graphing them and doing rise and run, you're just going to do y2 minus y1 over x2 minus x1. So what do we mean by that? Well, ordered pairs are listed as x, y. So x, y. Okay, but because there's 2 x values, we have to figure out which one are we going to call your first x value and which one's the second. Well, since this is the first ordered pair, this would be your x1 and your y1. Since this is the second ordered pair, this would be your x2 and your y2. Simple as that. Okay, so maybe good practice to kind of label those so that when you're plugging it into the formula, everything is cool. Okay, so let's go ahead and set up our little fraction here. So m is equal to, okay, and we're going to follow this format. y2, what's your second y value? Well, it's a positive 1. And we're going to subtract, and the reason why I say subtract is because that's what the formula says. I'm going to subtract my first y value. What's your first y value? A negative 3. Don't you dare just put a 3 down. It's a negative 3. You have to show that. So on top, you should have 1 minus negative 3. Okay. On the bottom, we take our second x value, which is 4, and we subtract our first x value, which is 7. Okay. So now we're going to go ahead and simplify this down. here we go. 1 minus -3. Well, if you remember, when you subtract a negative, that's the same thing as adding a positive. So it's the same thing as 1 plus 3. Okay. 4 minus 7, small minus big. That's going to be a negative value. 4 minus 7 is -3, sorry. So 1 plus 3 on top gives us a 4, and we have 4 over -3. So can we leave it like this? Is it simplified? So 4 and 3 don't have any common factors. They can't divide by any of the same number besides 1. So it's definitely simplified. Do I need to change it to a mixed number? No. Leave it as improper because that shows us the rise and the run. Okay, so leave it like this. Only thing I would do for my final answer, guys, is I would go ahead and stick this negative sign out front and make it look like this, -4/3. Okay, there we go. That's your review of slope. If you need to go further into this, then I suggest you look back at our slope videos. This was called Slope Part 1. And these two were on Slope Part 2. Okay, there we go. See you in class. Bye.